Hey everyone, in today's video we are learning about advanced pandas concepts like apply, merge, and group by through a real-world example in under 30 minutes. So here's a quick 30-second overview of our dataset and our problem statement. So here we've already read our dataset into this postings cleaned filtered data frame, and as you can see here, it contains information about job postings from LinkedIn. And we filtered down the jobs just to data related jobs. And these are the questions that we want to answer about the jobs as well. Now, to answer these jobs, we are going to have to add some columns using apply, add some data using merge, and we will have to group the data using GroupBy. By the way, if you want to see how we loaded, cleaned, and filtered this data set, that's in the first few videos in this playlist, so you can check them out there. So to answer those questions about the month and weekday where we have the most jobs posted, we're going to have to create columns that contain the month and the day of the week that the job was posted. Right now in the data frame, we have the listed time. However, when we print this, you can see that all of these values in here are floats because they're the date listed as a timestamp in milliseconds. So first, let's go over just how we can add a new column to the data frame without using apply, and then we'll do an example using apply. So let's reassign original listed time to itself, except we're going to run the pandas data frame datetime function, which will take a timestamp that's in milliseconds and convert it to an actual date. So to do that, we'll do pd.toDatetime, and we'll pass it this column as a parameter. And then we'll also have to tell it the unit that the current date is in, which is in milliseconds. So I'll run that, and now when we print out the first few values of original time listed, you'll see that it's actually a date. Now from here, we're going to create 3 new columns. We're going to create a column for the month that the job was listed and for the day of the week the job was listed. We'll also create one for year just so we have it in case we need it. So first, if we want to get the month, we will define a new column. So we'll call that listed month. And we're going to set that equal to the original listing time. We'll use the date accessor. This is similar to the string accessor we've used before. And that has a function called month name, which will give us the name of the month a job was posted in. So we'll run this line of code and then we'll look at the original listed time and the listed month so you can see that we're just getting the month name from it. So here you can see that the original listed time is April 14th here, and we're getting the listed month of April. We're going to do a similar thing for year and the day of the week, but you can see here we added a listed here, and just call that name. We added a day of week name here too, because the date object also has a day name function, which will return the day of the week a job was posted. And when we print out these values, you'll see that for this first one, it was posted in 2024, its listed month is April, and it turns out that that was a Monday. This is the most straightforward way to create a new column. You just define the name of the column and then you set it equal to a specific value. However, sometimes the value we want to set a column to for a row is a bit more complex, and it may depend on other values in the data frame. In these cases, we want to use a function to define the value. We then want to apply that function to each row of a data frame. So first we need to actually define the function we want to run. Then we have to pass that function to the apply function that's run on the data frame, and we have to specify if we want the function run on the rows or the columns of the data frame. So for our example, for one of our questions, we want to get the yearly salary distribution. Well, in the data frame, there are some jobs where the salary is listed as an actual salary, but for some of them, they're listed as an hourly wage. So for those, we need to convert those to an actual salary. And to do that, we're going to have to use a function. So first, let's define our function that will convert an hourly wage to a salary. All right, so what this will do is it'll take each row of the data frame, it'll check if the pay period is hourly and the work type column has a value of full-time. If it does, it'll return that row's max salary value multiplied by 2080. If not, which means that the pay period is not hourly, it is a salary, then we'll just return that salary as listed. Now let's define our new column, which we will call yearly salary calc. We don't want to reassign max salary because we want to keep that original one, but we'll run the function and save the result as a new column here. And we're going to set that equal to postings cleaned filtered dot apply. This is where we're running the apply function. And in this apply function, it takes two parameters. The first is the function that we actually want to run on the data frame. So we are going to run get salary. And the second function specifies if we want to run this function on each of the rows of the data frame or each of the columns of the data frame. In our case, we want to run it on each of the rows. So we'll specify axis equal to 1. That'll tell the apply function that we want to run get salary on each row of the data frame. All right, so we ran the apply function and now that we've run that, let's print out pay period, work type, max salary, and the yearly salary calculation so we can see how it's been applied. So here you can see we have some NAN values, and that's just because we didn't have a max salary for that column. If you remember a few videos ago, we did see that some values in max salary were empty. But here you can see that this is a yearly salary that's given and it's full-time, $65,000. Since it's a yearly pay period, we just left it at $65,000. But here you can see an hourly full-time salary of $16 an hour. When we multiply that by 2080, we get $33,280. So here you can see how that apply function worked. It went through each of these rows and it ran that get salary function on it. Now in this example, we ran the apply function on the entire data frame, and because of that, we had to specify if we wanted apply to run this function on each of the columns in the data frame or each of the rows in the data frame using this axis parameter. However, we don't have to run apply on the entire data frame. We can run it on just one column of the data frame as well. Said another way, the apply function can also be applied to a series instead of a data frame. So one column that I wanted to create was a job title bucket column. As I mentioned earlier, we'd already filtered the jobs to anything that contains the word data in it, but I wanted to group that a little bit more into like data analyst, data scientist, data engineer, and other data jobs. So to do that, I created this function which categorizes the job based on the job title. And I won't go too much into detail about this, but if you have questions, let me know in the comments and I can get back to you. Then here, this code is very similar to what we did for the salary column, except here I'm just defining a new column, job title bucket. And instead of running apply on the entire data frame, I'm just running apply on the job title column. I'm still passing apply the function that we want to run. Now it's the function get job category, but you'll see that the axis parameter is missing here. And that's because we are running apply on a series instead of a data frame. So a series just has rows. There's only one column in a series. So we don't need to specify the axis. Apply by default when run on a series will just apply this function to each row or each element in that series. So when we run this and when we look at job title and job bucket, you'll see that each of the job titles is categorized into a specific job bucket. So like data scientist is data scientist, analyst is data analyst. The last thing I want to cover when it comes to apply is lambda functions. You'll probably see this a bit when used with apply. So before we were passing a defined function to apply, but sometimes you might want to run a really simple transformation on a data frame or a data frame column without actually defining a function separately. That's where lambda comes in. Lambda is a keyword that specifies an anonymous function, which is just a function without a name. And it takes one parameter called x. So let's say we wanted to just square each of the salary values. We don't actually want to do that, but for example's sake, let's say we want to do that. So let's say we wanted a salary squared column. We would take our max salary column and we would use apply. Now we don't actually have a function that squares the salaries, but it's a pretty simple thing to do. So we can define lambda. Again, this is specifying an anonymous function, a function without a name, and we'll give it a parameter x. This x will take the value of each element in the max salary column. And what we want to do with each of those elements is we want to square it. So we'll do x times x. So what this lambda function will do in this case is it will step through each element of max salary, assign that element to x, square x, and then return it as the value for salary squared. So I'll run this, and then we can also we'll print out max salary and salary squared. And here you can see that this is the max salary and this is the squared value, and we were able to do that without defining a function, but rather using an anonymous lambda function. Now that all of the columns we need are created, let's talk about combining multiple data frames. One question we wanted to answer is which industry is hiring the most for data jobs. However, as you can see in our data frame right now, we don't have any information about the industry that the job is in. However, in the Kaggle dataset, there are several CSV files, and you'll see that there is one called Job Industries, and then there's another one called Industries.csv. So if we open both of those files, we can see in Job Industry that we have the job ID and the industry ID it corresponds to. And in Industry CSV, we have the industry ID and the industry name for that industry. So what we will have to do is we will have to take our postings cleaned filtered dataset that contains information about the job and contains a job ID. We'll have to merge that to the job industry CSV on job ID, and then we'll have to merge that merged data frame to the industry CSV on industry ID. Now that might seem a little bit complex, but it's easier than you think. And we're going to do this using the merge function from Pandas. So the first thing I did is I read in the job industries CSV and saved it as job industries IDs. And then the industries.csv file, I saved it as the industry names data frame. So we have two additional data frames here now. So now let's create a new data frame called postings with industries that will contain the result of merging our original data frame with these two data frames. We'll call it postings with industries. We'll set that equal to pd.merge. This is the function we're going to use to merge together the data frames. And it takes a lot of arguments. The first is called the left data frame, so one data frame that we want to merge on, so that will be our original data frame. The second argument is the right data frame. In this case, let's use job industries ID for our first merge, and then it also takes a parameter called on. What merge does is it'll take the left data frame and it'll take the right data frame and it will combine them on a specific column. And this is a column that needs to be common to both of these data frames. So in our case, job ID is in the left data frame and job ID is in the right data frame. So for on, we will specify job ID as the column we want to merge on. There's also a parameter called how. This specifies the type of merge we want to do. If you're familiar with SQL, it's similar to like if you want to do a left join or an inner join or an outer join, those types of things. This defaults to an inner join, but what we want to do is a left join. So we'll specify left here. And just a quick aside on the types of joins, a left join just means that we want to keep everything that's in our left data frame or our postings cleaned filtered data frame, even if it doesn't have a corresponding industry. It'll just put in a null value for industry if there isn't a corresponding job ID in the job industries IDs data frame. And I'll actually put a bit of a cheat sheet on the types of joins on the screen here, and you can kind of use that as a reference. All right, so now we'll run this code and then we will look at the first few rows of our merged data frame. So here you'll see we still have all the columns that we had before, but at the very end, you'll see we also have industry ID, and that is coming from our job industries IDs column. Now we also have to join to the industry name, so I went ahead and did that here. You'll see the code is really similar, except now we're just using postings with industries as our left data frame, industry names as our right data frame, and industry ID as the column we want to join on, because that is the same between these two data frames. I'll also mention that the column name that you want to merge the data frames on doesn't have to have the same name in both of the data frames. The merge function also provides a left on and a right on parameter as well. And here you can specify the name of the column in the left data frame and the name of the column in the right data frame. So if they don't have the same name, you can use these, but since we have the same names in our data frames, we can just use this on parameter. All right, so here you can see in our final merge data frame, we have the industry ID and now we have the industry name as well. Now there are some additional ways to join data frames together. You'll see concat used as well. That's used to combine data frames along a particular axis. Most often it's used to kind of stack data frames row-wise, but you can also use it column-wise as well. Another function you'll see is the join function. This is similar to merge, but it's mostly used to combine data frames based on their index. So if you already have what you want, the column you want to join on as the index in both data frames, you could use join. It's kind of a shortcut for merge if you're joining on indexes. Finally, we can answer the questions that we asked earlier by using the GroupBy function. This function is very aptly named because it literally summarizes the data by grouping the data frame by values in a certain column. Let's take the first couple of questions we want to analyze. How many full-time data jobs are being posted by month, and which weekday seems to have the most number of data jobs posted? So to answer question 1, we will take our data frame, our merged data frame, and we will run the GroupBy function. And this function takes a parameter which specifies what column you want to group the data frame by. So for our case, we want to group the data frame by listed month. Now, when we run this alone, it'll just return a data frame GroupBy object. To actually return values, we have to specify what we want to do when we group the values. So for this data frame, I think we have data from April and May. So it'll create one row for April and one row for May. But it also needs to know what values to put for each of the columns in the data frame. And what we want is simply a count of the number of jobs in each month. So what we can do is we can chain a count function to the end to this GroupBy function. And now when we run it, we'll see we get the data frame returned where listed month is the index of the data frame. The values are April and March because those are the unique values for listed month. And for each column in the data frame, it's done a count of the number of rows that have a value for that month. So here you can see we have 828 job IDs, 828 company names. You can see max salary looks like it's not populated for every single row that has a job that was posted in April. So that one's 776. And you can see we have that for each of the columns in the data frame. Now we can also just select certain columns. So if we just wanted to see the number of jobs, we could probably just select job ID. So at the end of this count function, we can select the job ID column. And we can do it like this because what this returns is really just a grouped data frame. And here you'll see we'll just get the series of job ID with the month the job was posted in and then the number of jobs in each month. And here you can see it looks like April had the most jobs listed, but it's possible that this data was mostly collected in April, so most of the jobs were posted in April. We can also select more than one column here if we wanted to. So let's say we wanted job ID and yearly salary calc here. We'll get it as a data frame. And you'll notice here that listed month is the index. That's just the default behavior of GroupBy. Whatever column you group the data frame by, it'll return the data frame with that column as the index of the data frame. But if we don't want that to happen, we can actually just do reset index at the end of this. And then when we print it out, we'll see that listed month is now a column. It's still grouped by the month, but listed month is no longer the index of the data frame. So we can always chain GroupBy by an aggregation function like count or mean or size or something like that. But there's also an aggregation function that we can use where we can define what function we want to run for a column. So let's do that for question number 2 of which weekday seems to have the most number of jobs posted. So here we'll take our data frame again and we'll do GroupBy. However, this time we'll group by day of week name. And now instead of doing like .count here, instead we're gonna do a .ag. This is our aggregation function. And this aggregation function takes a dictionary where we can specify the column that we want and what aggregation function we want to run on that column. So here we'll define a dictionary with the key of job ID, that's the column we want returned, and we want to do a count of the number of job IDs for each day of the week. So we can run this, and we see we get the day of the week name as the grouped column, and then we get a count of the job IDs for this data frame as well. Now we can also chain a sort values function to ag so that we're able to easily see which day has the most number of jobs posted. Now when you do this with a group data frame, you also have to give sort values a by parameter, and this will specify what column you actually want to sort the data frame by. So here we specify job ID, and we can see that it looks like Thursday is the day when most data jobs are posted, at least from March to April of 2024. So I guess if you're applying for jobs and you want to get your application in the first 24 hours, if this trend is still holding today, then Thursday might be the day to do that. So I also went ahead and I answered those other two questions we had, which were which city has the most data jobs posted and which industry has the most data jobs posted. And I won't walk through it in too much detail, but you can see the code is the exact same. I just use city and industry name instead. So it looks like for city, New York City, Seattle, and San Francisco have the most data jobs posted. I think that's fairly expected. And then for industries, it looks like IT consulting and financial services have the most data jobs posted. So let's go back to grouping by city. We can also add in additional columns to this ag function. So let's see what the average yearly salary is for data jobs by city. So in this dictionary that we've passed to ag, we can specify a new key value pair. And here we'll specify the column yearly salary calc. And for this, we want to find the average. So we want to run the mean function on this column. So now when we run that, we can see we get the count of the job IDs, and then we also get the average yearly salary. So here you can see for New York City, it's around $200,000. For Seattle, it's like $184,000, and so on. And you'll see United States is listed here as a city as well. I think some of the jobs didn't actually have a city, so they were just listed as United States. So we can actually just ignore that column for now and really just focus on the cities. That's something that if you were doing this analysis more in depth, you might clean up or remove or something like that. Now, something else we can do is we can also add a list of aggregation functions that we want to run on a column. So let's say we actually want the min yearly salary, the mean yearly salary, and the max yearly salary. So now you see we get a multi-index data frame. So we have job ID and count, and then for the yearly salary calc, we have the three aggregation functions. We have the min, we have the mean, and we have the max. Now we can still sort this data frame, but that by column is going to be a little bit different. We'll still have ascending equals false, but before we had job ID like this, but now that it's multi-index, we'll have to specify job ID and count as a tuple. So we'll do that here. We'll do job ID and we'll do count. Now when we run this, we'll get it sorted by the count of job IDs, and you'll get the min, mean, and max salary. So here you can see for Seattle, the min yearly salary is $48,000, the max is $337,000, with an average of about $184,000 a year. Finally, we can also group by multiple columns. So let's say we wanted to see a count of jobs by the industry and by the job title bucket. So that was that data analyst, data engineer, other data jobs. So we'll actually take this and we'll copy it down here. And now, instead of passing just one column name into GroupBy, we're actually going to give it a list of column names that we want. So we want to group by industry name, and we also want to group by job title bucket. And everything else here can stay the same. We still want to count the jobs. We still want to sort it by job ID. And now when we run that, you can see we get the industry name and the job bucket title, and then the count of jobs under that specific industry and job title bucket. So you can see that IT consulting has 62 jobs that are other data roles. That means they're not a data analyst, data engineer, or data scientist. Here you can see that IT consulting also has 27 jobs listed for data engineers. So that's how you would group by multiple columns. Now, the very last thing I wanted to cover is doing basic visualizations in Pandas. So one of the questions we didn't answer yet is the distribution of the yearly salaries for data jobs. That's a question that is probably best answered with a visualization, and we can do that using Pandas and Matplotlib. I did want to quickly cover how you can do a histogram using Pandas. So first, we will have to import Matplotlib, which what we're doing here. Then we're going to take our merge data frame, and on that we are going to do .plot.hist, and this will create a histogram of whatever column we specify. So this hist function takes a few parameters. The first is column, and this is the column that we want to visualize on the x-axis, and that we're going to make yearly salary calc. We'll give it a function of bins, which is the number of bars we want in our histogram. So we'll just set that to 50, and we'll set density equal to false so that we get a normal axis label. And now these are just some Matplotlib attributes that we're setting. So we're going to set the X label to be max salary. We're going to set the Y label to frequency, and then we're also setting some tick label formats. This just tells Matplotlib that we want the axis to be plain and not in like scientific notation or something like that. And now we can show the result. And here you can see we have yearly salary. Here is the salaries and the number of times a salary appears in that bucket. So it looks like we have salaries mostly around like that $150,000 to $200,000 range for all our data jobs. Now we can actually break this out by the data job bucket. This histogram function takes a by parameter, and for that we can specify the column that we want the visualization broken out by. So for us, that's going to be job title bucket. And now when we run this again, you'll see we're actually getting 3 different histograms, one for data analyst, one for data engineer, one for data scientist, and one for other data roles. And you can kind of see how the salaries differ by that job title. So that was just a brief overview of how you can do visualizations in Pandas. There's other functions here other than hist. You can do different types of charts as well. I actually have a video on Matplotlib, which gives you a little bit more control over the styling of the charts and all of that. So I'll link that at the end of this video if you're interested in visualizations. All right, so there we have it, advanced Pandas in under 30 minutes. I really hope this video was helpful to you. If it helped you feel more confident with things like apply, group by, and merge, I would love it if you considered subscribing to this channel and liking and sharing this video. With this video, we're also at the end of our Pandas series. I really hope these videos were helpful for you. If there's anything that I missed in the Pandas series that you were wishing that I covered, let me know in the comments below and I might be able to make a future video on it. Thank you so much for watching this video and all the videos in the Pandas series, and I will see you back here next week with another data analytics video. See you there.